Lucia? Yeah. Shall I say Lucia or Lucia?
How do you feel?
I feel like Lucia.
Okay, then you say.
But that's more accurate?
No, I think both. You know, depends on where you have my mom or my dad.
Then it's crucial.
Well, I don't want to get there.
Okay, we would like to proceed. Please sit down.
Do you have your gong?
Okay, it's a great pleasure to introduce Lucia Melloni from the Max Planck Institute.
It is on.
Lucia Melloni from the Max Planck Institute for Empirical Aesthetics. She'll be talking about the role of predictions in consciousness. It will be wonderful to hear after all our arguments all the time. Lucia, please.
Thank you. First of all, I want to thank Leon and Daphna and the people at the IIS for having us here. You are coming after a couple of months that we have been here dwelling on consciousness and trying to understand what we are talking about. And I think that the first talk was a good reminder of the problems that we are facing. And in the space of the deconstructing and reconstructing consciousness, what I'm going to do today is to try to build a story to then tear it apart. So the story goes that many years ago, and I guess that we have all stumbled across these kind of images, where we look at an image, we say, well, that's a black and white, thing, I don't know it. Then I show you this image, I go back, and voila, your perception change. And it will change forever, which is this weird thing. So there is this one-shot perceptual learning where something that supposedly didn't have an impact on consciousness did have, which is our memories and our experience. And I thought, wait a minute, so I was in this mode of destyling the correlates and thinking of all of the processes that have nothing to do with consciousness. And here was one where it was just right obvious that it did seem to have an impact. And this just can happen in a minute, as I show you now, but it can also happen across our lifetime. So if, for those of you who grew up around these clocks, you may actually perceive the tilt as different from the one here. And the tilt is in essence the same. The only difference is that, if we look at those all the time, we integrate those, they become our priors, and we then discard the tilt, right? And that's why then we have this, strong adaptation. So then again, there's this, memories, experience, learning, where either our experience changed forever and it has been changing across our lifetime, or it has changed in a minute, right? And I thought, how can we actually understand consciousness from this perspective where memory seems to play a critical role? And of course, there is always somebody who has said something about this. And one person that has been thinking about a lot about the role of priors and memories and learning is Carl Friston in the context of predictive coding. And say 10 years ago when I was thinking about this thing, predictive coding wasn't a thing. Now it's a thing. And the thing goes like this. It goes that, the idea that Carl has is that perception, first of all, is constructive. So we don't have, and for that matter, consciousness is also constructive. There is nothing like a reality out there and that we're really just mirroring it. Through our experience and through our memories, we are getting a construction of what it is out there. And how do we build that? By actually having feedback. So in this case, imagine that you actually are perceiving something. The activity goes to, say, early visual areas, it goes into layer 4, it goes up, but then it will actually be changed by feedback from higher cortical areas. And that feedback will be either our experiences before or our memories. So this is an interesting framework whereby learning, memory, and perception are all entangled into one. And this will actually, what is interesting about this framework is that these priors are hierarchical. So they can actually come from something, very unspecific, like say a word, right? And then, say in a specific tone, I'm saying house, it's my voice, it's my pitch, and etc. You can actually predict to the level of, what would be my sound. So it seemed kind of like obvious that this framework would be interesting and relevant for consciousness. And we started by saying like, okay, let's assume that actually it does. But what is the problems that we face when we embrace this framework? And the first one was something kind of like simple, but this is how it started in the first experiment, that not all predictions are equal in regard to perception. They actually work in different ways. In the first image that I show you, they stabilize perception. It makes sense, right? So the world keeps changing. There's all sorts of like very low level differences, and nonetheless, I keep seeing Rafi even though the light is constantly changing. So priors will stabilize our perception. That's kind of like clear. But they also do this other weird thing that I showed you before. They generate adaptation. So they actually shift you away from what you actually thought. So the question is, well, so if not all predictions are equal and they influence perception in different ways, how are they implemented? And the second one is, if we really think of, if we embrace this issue of, well, we have a history, and whoever we are is a history that we had before, then this means that we will have perceptual phenotypes. Like everyone is going to be different, but in actually systematic ways that we can also investigate, right? And the third one, that is another aspect that Carl has talked a lot about, but we tend to forget, is that predictions not only matter for perception, but that action also it's like a perception action cycle. So we can either change our perceptions, or we can change the way in which we sample the world to actually be it conformity with our predictions. So how are we going to close the loop if we really embrace this framework? So let's start with the first one. So as I showed you before, if you have never seen this image, I do this, I do that, it's clear. Priors will stabilize perception. In the other case, I'm going to just give you an example as to how they actually shift us apart. Where's my mouse? Here, sorry. So I will ask you to look at this dot and keep fixating, right? And this thing is going to move, and then eventually it's going to stop. I'm going to ask you in which direction you actually see the lines, right? So let me see. So here we go. You see them parallel or not? Okay, so that's exactly the point. So they are parallel, but because you have been seeing them in the different perspective, then you actually tend to see them shifted, right? Again, it's constructive, it's just based on adaptation, right? So in reality, when we think about this, how priors affect our perception, they will do it in these two ways, which we call exploration and exploitation mode. And it's actually relevant because if we are always seeing what we expect to see, we would also be missing, like if you think of foraging, I keep, feeding in the same place. Well, at some point, the food is I'm going to run away of food. I'd rather be also just looking at the other alternatives, right? And you can think also, if we think of curiosity, it's another way in which we can, think of a mechanism for curiosity. We always need to explore the others. But how do we go away from how do we explore the others? By knowing what we know, right? So it's also, it serves a dual purpose. So how do we investigate this? We go to this this is going to be actually an opposite talk, from Leah's talk. So this, we like dots, we like completely, artificial stimuli, but they are artificial in interesting ways. So I show you this, they are multi-stable images. So you can either see them as lines that goes in this direction, or in a third direction, I don't remember which one. And I ask the subjects, in which direction do you see those dots? And we can vary perception of the subjects by changing the so-called aspect ratio, right? So if I show you this one, you tend to perceive this direction the same way. If I change the ratio here, you tend to align the dots along this direction and the way around in this direction, right? So then by changing the amount of information, and this will become relevant later on for the case of adaptation, because remember that you tend to shift away the more information you have. So if I do, as I showed you before, if I move the lines very, very much in one direction, you will tend to see them in the other direction, right? So this is how we're going to try to manipulate adaptation. And secondly, we present this lattice that is actually, it's tri-stable. So you can see it in three different directions. We always show the same, right? And this is the impossible task for the subjects, right? And this is how, we kind of look at the effect of the priors, because we only manipulate this one. but the effect on perception, we keep it the same, right? So in this paradigm, what you will have is the so-called like hysteresis, which will be, subjects choose here one orientation, and we then sort the trials by how often did they choose the same orientation versus how often they chose a different orientation, right? And you can also look at adaptation by how much the orientation that they choose here is determined by the amount of information that we give them before, right? All right. So in this plot, so what you can see here is this is how much information we gave. So in this case, and this is the behavior responsible for the first stimulus. So in this case, we bias the subjects to perceiving the 0 orientation, and they're actually lawful. So they perceive it at 0, much more probable. Here we bias them to perceive them at 90, and they are also lawful. So we know that they are doing the task properly, right? What is relevant is what are they going to choose in the second one that is just the same. So we have been presenting for the whole experiment the same stimulus, right? And what happened is that they chose. Now the more they saw one orientation here, the less they're going to see the orientation there, right? And that's the effect of adaptation, right? As I showed you before. So this one goes this direction, the other one goes this direction. So if they chose 90 very little, they're going to choose 90 a lot, and the other way around, right? And now you can also sort the trials by not just, we're actually not sorting them, by the way. We're just looking at what the responses are, right? The way in which you can look at hysteresis is how likely they are to choose the same orientation. So in this case, this line represents how often they chose the 0, having chosen 0 before, and how often they chose 0, having chosen 90 before, right? And the fact that it's parallel is really cool for us because it means that these two effects are independent, right? Behaviorally, at least. So now the question is, so now we have a grip on a paradigm where we have these two priors. Again, it's absolutely artificial, but we have a very good grip on what we are looking at. And we ran the same experiment now with the subjects in the scanner. And we looked for what are the areas that we have this distinction. So now, again, we are sorting the trials, we're showing the same images to the subjects, but we're sorting them to what they saw before, right? And the areas that you see here are areas that actually make this distinction, the difference between having seen the same versus switching between one and the other. What is conspicuous is, first of all, that we don't see early visual cortex activated here, but more like IT or fusiform gyrus, IPS, and the dorsomedial prefrontal cortex. What else did we see? That also whenever subjects saw the non-predicted orientation, they actually have higher activity than when they saw the same orientation twice, right? And this goes, it's not evidence for anything, it's just an observation, right? Now, an interesting finding that we had that we were not expecting was this area, the dorsomedial prefrontal cortex. And was the only area that correlated with the behavior of the subject. So the changes in that area correlated with how strongly the subjects would have the hysteresis effect. And this just, it was an observation, but we chased it. Because we thought, okay, that's interesting. So now but this was fMRI, we didn't really have a good grip on what was going on. So we thought, okay, let's just go to intracranial recordings. So in this case, we had 6 patients doing the same experiment as our, poor healthy volunteers. And they had electrodes either in the dorsomedial prefrontal cortex or in the lateral prefrontal cortex, right? And again, they did the same experiment as before. And what we have again here is we take the trials where they chose the 0 orientation, both times. So the choosing is the same. But all that is the difference is what they had actually chosen in the time before. And what you see here, this is the effect sizes. So around 300 milliseconds, there is an increase in the activity in the middle prefrontal cortex for when the subjects actually change their perception. We didn't observe that. Now when we go into the lateral cortex, that difference actually is not there at all, right? Now, what I was showing you here is the activity in the so-called high gamma. This is something that we typically tend to investigate in intracranial recordings. The question was, is it specific to that frequency band? Because there's some theories that actually think that it could be other frequency bands. What we observed, and again, here is the effect size. This is the high gamma. This is really, really big. None of the other frequency bands actually contributed as much. The only one that actually does it a little bit later on is theta. But we saw nothing in beta, nor in low gamma, nor in alpha. So it's only specific in this case to high frequencies and theta, but later on. Again, one criticism that we had at the time when we had that paradigm was how much is this related to perception versus choosing twice the same thing, right? And we had actually taken care of one thing I didn't mention, but the subjects had to choose the responses. We presented them 4 different options, and the option that they chose was randomized for the second one. So at least what they click on the screen was not the same. But you could say, well, but at some level they had chosen twice the same thing, right? So what we did here was to show them, in the first case, a cloud of dots. So there was no orientation there, and we asked them, like, just choose something, And if this is a choice, we can now sort the trials again based on choosing twice, right? First of all, we did not observe behaviorally any hysteresis effect. So there was nothing that, because I chose something before, I will choose it again. No, in this case, we didn't observe that. But also, the dorsomedial prefrontal cortex didn't have this increase in high gamma that we observed before. So we believe that this is just not decisional per se. There's something to do with perception, how much those priors affect the way in which we perceived, right? Furthermore, we had these rare opportunities to actually encounter a patient who actually had a resection of that area because she had epilepsy. So it wasn't a stroke. It was a neurosurgeon who came with and make a very nice cut on that area, right? And we just happened to, have her in the unit. So we thought, okay, if this is true, and this area is so important, maybe, we wouldn't observe hysteresis in this patient, which in essence is actually what we observed. So this is the patient. This is how often she chose the same orientation versus a different orientation based on the previous option. You can see there's nothing. And in the non-lesional cases, we actually have a big effect. You could say, well, it was an epilepsy patient. What about the rest? This is all of the sick cases that actually we had. She is here. So her effect size is really minimal, to non-existent. So it seems, okay, it's one case, granted, but it's one case, somebody that, it's not a stroke. Right? Okay, so then at least from this data, we can conclude that this area seemed to actually really play a role in stabilizing our perception. Now, what is the mechanism, or what are the areas related to changing our perception? And in this case, we were inspired by how adaptation works. And we know that the more information we give into one orientation, the more we kind of fatigue those neurons, right? So we took that logic, and the idea was, in this case, imagine that I have a bistable one, so I give information for both orientation, then you would expect that the population of neurons that do 0 and 90, they activate to the same degree, and then therefore when I show the next stimulus, they also go down to the same degree, right? But if I actually take a stimulus where I don't have the same information, in this case what you would have is, for the first orientation you would have a difference, so in between 90 and 0, but then when we present the very same one, then we're going to have reductions in the activity, right? And their one would not reduce as much. Now, in our experiment, the reason why you see it, higher is because we're only choosing the orientation for which we gave the least information. So that's why you see the most repelling effect. And what we observed is that the only area in the whole brain, when we looked at everywhere, that chose this pattern was a very narrow area between B2 and B3, right? Then we did, when we took, again, much like in the behavioral effect, when we took the activity in these areas and we looked for hysteresis or the other way around, we did not find the other effect. So they actually really seem to be separate networks. Now, when can actually post-hoc, make a model. I'm not saying that this is pre-hoc, but it's post-hoc. A model as to how the effects actually that we observe are happening. And here again, the Bayesian framework is interesting because we can actually have a distinction between the sensory evidence and the priors. And we think that if we actually use these two different terms, we can accommodate the adaptation phenomenon and the hysteresis phenomenon. How we can do that? We think that the hysteresis alters the prior versus the adaptation, in this case the repulsion effects, actually alters the likelihood. And since they actually map into independent terms, you can actually have mixes of both of them, right? It's just a model, we haven't, it's an alternative model to the ones that are in the literature that actually postulate that both of those phenomena are done by the same parameter. And we thought it was not, at least based on the brain data, doesn't seem to be the case, that they are actually the same. All right, so far so good. So it seems that there is, at least that the higher level priors map into higher cortical areas, the adaptation maps into lower cortical areas, fine. But now, can we understand different phenotypes of people based on the same framework? Why can we not? Oh, there you go. Based on the same framework. And we thought, okay, there is, at least in the literature, we can think of people who are actually different already just to start with, or that we think that they are different. On the one end, we have people that suffer from schizophrenia, and what has been described in the literature is that they actually tend to be much less prone to perceptual illusions, right? On the other spectrum, you have people that have synesthesia. I don't know if you know, if you don't know about it, this is people who they are neurotypical people, but they tend to see, for instance, letters in a particular color, and that's systematic. Everyone sees it in a different color, but every time you show a synesthete who sees an A in red, it will see it always in the same red, right? But then another synesthete will be yellow, but it will always be yellow. So in that sense, there is intra-subject consistency, not inter-subject consistency. And we thought, okay, can we try to understand from this very same framework people who actually have these two different, spectrum of perception? And we took a paradigm that we had done, many years ago, where we present noise, and then we showed in between the noise, we present letters, and we unravel them, like little by little. So, and as you see here, in the strongest case, you can see a very clear letter A, and then what we do is we put it back. So in this case, we go from a lot of noise to seeing clearly an A, and then from seeing clearly an A to seeing noise again. What happens in perception is the so-called hysteresis phenomenon, which is that the threshold will change just because you have a prior. So you continue seeing that A for longer times, right? And the question that we had was, what will happen? So what will be the moment at which synesthetes and schizophrenics and normal population will see these letters, right? The prediction was, if synesthetes have a prior, they will start seeing that letter earlier because they have an extra cue, color, to actually perceive the letter. If the schizophrenics actually are less resilient on this are less prone to perceive these priors, then they will be much more relying on the sensory evidence. Therefore, they will see it later, right? Okay, and then the letters that we chose was, so for each synesthete, we asked them, to pick their colors, and then we would just map displays into the different colors. We also can turn a synesthete into a non-synesthete by showing them symbols. Right, so then you actually have intra-subject control, right? So you show them, like again the same color but a symbol, and they shouldn't have anything. Like they should behave like normals, right? So what did we observe? This is the curve when we actually showed the so-called synesthesia-inducing stimuli, and as you can see here, these are the normals in red. These are the schizophrenics, so they actually tend to perceive them. They take much longer to perceive them, and these are the synesthetes. They take much less information to perceive them, right? But now, if the experiment goes well, it should be like this, right? Because the synesthetes should be like us when they are seeing symbols, right? And in fact, they are. Nonetheless, the schizophrenics actually are still being less reliant on these priors, right? Now, as I told you, the one interesting thing that these experiments allows us is to see, like, by how much, once they have seen the stimuli, they can rely on those explicit priors. Like, I know that now I'm seeing an A, right? And now Leah explained you how to read this plot. So this is the decrease in Planck, when you go down in the information, when you go up. And if you're in the identity line, then this means that your perception is actually the same when you go up and down. If you are in this direction, then this means that your perception, you continue seeing it for longer time. This means that you need less information to continue seeing it. So in this case, you see the stimuli, you see like in level 2, here you see that level 1, right? So, and it's the same stimulus. And what you can see in this case is that for the synesthetes, the controls, and the schizophrenics, everything is in the line below. So they seem to all be equally relying on those explicit priors, right? Which is good news and bad news, because we thought, okay, if schizophrenics are relying, could it be that because we give them explicit priors, now they can overcome, well, no. They're just, giving them or not giving them these priors, okay, make them to profit from them, but the same degree as everyone else. And if they started from a lower baseline, they just can't overcome that, which is what you see here. So all of them profit from those explicit priors, but it's not that schizophrenics profit more or synesthetes profit more. All right. Okay, this is just the same, just to show you. Okay, so it seems that at least based on this framework, we can characterize people. Doesn't tell us much, but at least we have a grip on, we can use the computation in this case, to characterize people, right? The next aspect of the predictive coding is that our perception should change, but also our actions should be informative as to what we perceived, right? That's the other end of the spectrum. And somehow we know that this is the case because if, for instance, I show you this image, and I ask you to look, for instance, for the gender, or for how rich or how poor people are, or like how many kids, blah blah, your patterns of eye movements will change depending on what the task was. So we know that our motor control reflects what we're looking for, right? So good, because I just have 5 minutes. So what we thought is, okay, can we now use the eye movements to unravel or kind of have a grip on the priors that these subjects may have, right? And Raul, what he did is that he took images. In this case, you can take the contours, and by making the dots closer or further apart, you can actually mimic those contours. So now you actually have a good grip on what you're seeing based on the proximity of these dots. And we did the same experiment as before. So we went from this completely homogeneous pattern to something where you could see, and then we went the way around, right? But in this case, we ask, what is the patterns of eye movement that the subjects are going to have? And how is that going to be informative for the priors that they have? And what you can observe is if they know nothing about what they have to see, and you give them this impossible thing where there's nothing, they just keep looking. These are all the fixations that they have. As you give the information, the patterns of fixations reduce and concentrates on what it should be. What is relevant and what is more interesting for us is what's going to happen once they know they revisit the very same image. Well, now what happens is that people, first of all, they fixate much less, which is what you can see here. So the fixation spread is actually much smaller. And why? Because when we actually look at the images, what they do is that now they go into the points that are actually maximally informative. So you go and test your priors. You don't need to go and sample everything randomly. You just go and pick that information that allows you to see what is the image that you had in your mind. I say okay, I'm seeing a canon, right? So that's why people don't need to, just look around. All right. Then finally, the next thing that we started wondering was, we do not only have a perception of the things out there, but we also have this inner sense of our body, right? And this is what we use to interact with objects. How much that this inner sense of our body will affect the way in which we perceive the objects. And there is a very long line of research started by Patrick Haggard, where they looked at how do we perceive the size of our hand. And you would say, well, it's veridical, right? I mean, I live with my hand, I touch my objects. But if I ask you to close your eyes and point where you think your knuckles are and where you think your hand is, you're going to distort it in a very systematic way. You're going to think that your fingers are shorter, and that this palm is actually wider. So we have a very, very ugly hand, in our head, right? It's shorter, think of, and this happens for both of your hands, left and right. So it doesn't even matter where, you write more. No, both of your hands are going to be distorted. And the question was, so if this is the case, what happens with the objects? So if we're always, again, in this question, do we perceive them veridically? Because if we perceive them veridically, how do we interact with them? So what Valeria did in this case, she ran a task, which I'm going to explain in a minute, and she asked, okay, let's ask the subjects to estimate the size of their hand, again, the length of their fingers and the width of their palm, and also objects that they interact a lot. In this case, we thought at the very beginning, let's just ask for a control stimulus that we have as much familiarity as our hand, our mobile phone. Surprise, surprise, I'm going to show you later on, so it didn't turn out to be a control stimulus. Then we thought, okay, now let's ask the subjects to estimate the size of their own mobile phone versus some other's mobile phone. And you would say, well, I know a lot my mobile phone, I don't know yours. I may have different, unless I have this inactive view, right? But also, what happens when I show you a fake hand that looks literally like you? It looks like yours, but of course it's not yours, right? What happened with other objects? Again, like a fake hand and a mag that we use a lot, right? And what happened with stuff like a cactus that, of course, we would never touch, right? Or things that are disgusting. She went, through the trouble to actually put, like hairs and make it very disgusting like a soap, right? And then also mouse that we actually use all the time. So these two are literally very similar in shape, but you wouldn't want to touch this one. But this one, you're okay, right? And she had a task whereby the subjects had to, first of all, look at these objects for 3 minutes before, only for those that they didn't have exposure. And the assumption was that, okay, I don't want to overemphasize exposure to your own mobile phone. And then she presented on the computer screen lines that were either horizontal or vertical, and she varies the length of the lines, and asking the subjects, think of the length of your hand and tell me whether this line is actually smaller or bigger. Right? And that's how she estimated the perceived size of the objects. So the first thing that we found out is much like what has been described before. First of all, in our experiment, which we still don't understand why, we tend to perceive everything as smaller. All of the objects, not just the hand, all of the objects. But what is relevant is how we will distort the horizontal dimension and the vertical dimension, right? And we replicated what Patrick Haggard has found before, that we distort more the vertical dimension than the horizontal dimension, right? What was interesting that she found was that we do the same thing for the mobile phone. It doesn't matter where it's mine or it's yours. I will just distort it the very same way, right? What happened if you, with a mouse and with a mag? The mouse, you could say, it's, at least it's something similar to the mobile phone, but the mag, we touch it in different ways, right? So we thought, okay, it's kind of like a control object, the same distortion. But interestingly, you perceive veridically a fake hand, and we have replicated this across 3 different experiments, so 3 different populations. So a fake hand, it doesn't matter, you will perceive it, the horizontal and vertical dimension will be fine. Now, what is interesting is what happens with the cactus. You now actually distort in the other dimension, So the things that you don't interact with, you distort in the other one. So this is now the patterns of distortions when we put all of the objects together. So we have, on the one hand, what we think are objects that we interact with all the time, and we tend to distort them similarly. So our own hand, a mouse and a mag. The mobile phone is closer to our hand than objects that we will not interact with, right? Now she thought, there's just something weird with this, fake hand, why? So we thought, okay, maybe it's because we don't have the sense of ownership. If you see a fake hand, you wouldn't even want to touch it. It's it's like an alien thing, right? So we thought, can we change the phenomenon if we make this hand to be a part of your own body, right? So you can capitalize on the so-called rubber hand illusion, right? So you put the hand there, you touch it synchronously with your own hand, and you kind of tend to have a perceptual drift. You think that your hand is actually the thing that is on the table, when it wasn't. To cut the long story short, it didn't make any difference. So if it is your own hand, you're going to have the distortion, whether you have the rubber hand or not. Pre and post, it doesn't change at all. And if I show you the rubber hand, I can do the perceptual illusion and everything, and you're going to nonetheless perceive these objects as something different. So, Yeah, so at least we can tell that it's not the sense of, like I own it. All right, so just to conclude, I hope that I build a case that seeing is imagining that there is a face in there, and face in there. So we just believe more than what we really see, right? Again, this case, I guess that, for those of you who don't know, you would say, well, these two gentlemen are actually very different. Actually, they aren't. It's the same person. It's just, your history of, okay, you tend to map this into different prototypes than the other one, but they are in essence the same, right? So does this mean, however, through all of these, studies, I think that we have good evidence for is that predictive coding is a good theory to understand some aspect of perception. It explains, like the different priors that we have. It could actually make us help, the different perceptual prototypes that we have. Also, the actions that we make and how that how we interface with objects. But does it make it a theory of consciousness, as some people claim? And I don't think so. I really think that there is no way how predictive coding will be a theory of consciousness. It's a theory of many things, but not of consciousness. Is it nonetheless useful for us to understand consciousness? And I think it is. And we should continue doing it, and that's all fine. But thinking, and I think this is an important, because in that sense, predictive coding has been claimed as a unifying theory of the brain. Well, I would claim that consciousness is part of my brain. So it explains certain things, but not all of them. And to conclude, I hope that I, build a case that predictions do play a role in perception, and therefore we need to probably investigate more the role of memories into our perception. But they have these really weird roles. Like sometimes they make us to see the same, sometimes change. They can explain the perceptual phenotypes, and something that we should probably do more is what is the perception action cycle, and how do those priors will interact with in our actions. So thank you.
Thank you, Lucia, for a very elegant set of studies. You choose the question, but I ask that you speak into a microphone because this is also broadcasted.
Thank you for the beautiful talk. The last part of the talk, for instance, subjective distortion of sizes, so on. What do you think it's related to conscious processing? Maybe you can test it with unconscious paradigms.
So you're right. What we were trying to make a case for there is that we have a sense of our body, and that will affect even the things that like we are seeing, right? So and that
yes,
that
but
was
this
it's
would be
nothing to do with
also a prior which is affecting unconscious processing.
Absolutely. Okay. It's more to close the loop that what we see is not only like it has to interact with like how am I gonna, or it has to relate to how I'm gonna interact with that object, and that is something that we don't usually take into account. That's it. But you're totally right that it can be absolutely unconscious. Yes.
Hey, thank you. I couldn't agree more with the overall message. I wanted to ask specifically about the mechanism of stabilizing of perception.
Mm-hmm.
So why you could call it stabilization of perception. You could also call it some form of interpretation or top-down perception. What constitutes the stabilization thing? So it's true that once you saw the dog, you always see the dog. But is this the essence of what this process is doing, or maybe the essence is just labeling or categorizing and so on? It's not related to stabilization over time. That's the question.
So there is. Well, I didn't actually have I didn't have time to show the data, but it's not just labeling because it interfaces with the amount of information that you give, right? So you're not hallucinating, right? And how do we know that is because you know, for instance, if you're seeing disorientation and I shift things, there's only up to a point that you apply these priors, right? So in that case, you could say, well, you're applying a label of, a category boundary. Could be, but, like, and then it becomes like semantics, that, what do you really mean by that? We know that when you think of, how do these priors actually, relate to perception, that with the categories it's actually interesting because you can think of, when we looked at the letters, for instance, if you tell the subjects A, right, they will also see the letters earlier, right? And you can also think that it's not necessarily only, like categories, but that you also have a specific idea as to what it would be. And we tested that by, for instance, so if you say A, A is an interesting case because you can have an A like this or an A like that, right? And what they will see depends on actually what they actually had imagined specific. So it's not category per se, right? So yeah, that's right. You had that.
Well, of course, I never thought that I would be in a position to defend predictive coding as a theory of consciousness. But of course, the broad version of predictive coding is that predictive coding is also present in, say, the interaction between feed-forward and recurrent connections as they are already established by means of learning and what have you, of course, and maybe also genetically. But of course, the experiments that are mainly done about predictive coding is how these connections change. And of course, that changing is not a theory of consciousness, but rather of, say, learning. Yeah, I can agree to that. But the more general version of predictive coding, in the sense that that the interactions between, the feed-forward activation and the already established recurrent activations might still be then a theory of consciousness. Or would you also say that this is not a theory of consciousness?
I would say both no. So my understanding of predictive coding is that it's also a theory of learning, and that's why like Carl is really pushing for it, right? Because like these priors are not just once, and you never change them, right? Now, and that's what he called like inference and like the moment by moment. But even if you actually just take the snapshot view, like then what begs the question is, okay, if I have this hierarchical predictive coding of everything, like from the higher areas going down to the lower areas, if that principle will explain consciousness, it will have to then tap into why some of those priors will affect my perception and some of those won't, right? Because it's not the case that all of them, like affect your perception the same way, right? So even in that case, you would need another, like cut to say, like, well, only when it's, like IT to B4, but not when it is B2 to B1, right? So then it won't just fall out of the theory that the feed forward and the feedback will do it, right? Unless, like, I mean, you may have a different view there, right? But, at least in my view, like, I don't understand like why, some of them will actually impact and some others won't. Wait, so there we have her.
You can have different types of priors. So for example, you can have a very simple prior, which is the effect of memory. A very simple synaptic memory without a kind of a hippocampus or anything like that.
Correct.
And this will affect the way that you will that you will react to a new stimulus, and it will prime you.
Correct.
So this is also a kind of a priming effect,
Yes.
which is very different from the requires some kind of hierarchy. Nevertheless, you do have memory systems, which, like the hippocampus and other systems in other kind of animals, that are sort of superimposed on the very, very simple memory system that you find between locally. Can you explain in what way the priors that you are describing are different from this kind of memorizations?
So this is what the case I was trying to build for the hysteresis and the adaptation, right? Because you can think that adaptation is a local phenomenon. So in this case, so that's exactly actually why we went into that, because we were thinking of, okay, memories are they function in the brain in different ways, and they not necessarily all will have the same phenomenon, the same effect, right? So what is even more interesting is that, for instance, if you think of the adaptation, what it didn't show is that you can have adaptation to an orientation that you never saw. So I think it also has an interesting aspect because it tells you that this local phenomenon will have an impact on your perception, but it will have an impact even when it's unconscious, completely unconscious, right? So the only thing we can say is that, like they impact perception, they are mapping to different mechanisms, and they may exert the effects also in a different ways, right? Even more interesting as well is the fact that, when I was explaining to Leah the hysteresis, for instance, by how much you can shift or you can keep your perception the same is also different from the adaptation, right? So in this case, just very little differences will not have the same effect, right? Whereas in the case of the hysteresis, you would actually have a longer effect. So it could also be something that Stan has been hypothesizing before with these windows of integration, and why also consciousness may integrate over longer time scales. And it also seems to also map onto higher order areas, right? So you can think of these two as lower order, shorter windows of integration, it can impact unconsciously. Higher order, longer windows, it can impact consciously. But it's just speculation. I mean, it just seems to map. And so, Mike.
Thanks for the talk. It's two comments, if you don't mind. I mean, one is predictive coding. I just think that we might, or let's take the hysteresis phenomenon. Instead of articulating in the language of priors, I would just think of articulating in the language of interrogation. I mean, we see in accordance with the questions we ask of the environment around us. So I think that might be a more useful concept. And then the second point I want to make maybe it touches on what Victor asked you, which is that the idea that there's that feedback between areas confers some kind of prediction, I think is based on a mischaracterization of the neuroscience, which is that I would say the fundamental fact is that there's no example we can come up with where a neuron that receives feedback shows any signs of the response properties of the neuron that's feeding back. So I don't think we can evoke feedback connections as support for predictive coding.
First I don't, I think you're going to have the chance to explain in your talk more like what you think of the affordances, but I don't understand, like how to, why you cannot think of hysteresis as a memory. But for the second aspect of your question, so I think there is new evidence. So for instance, Casper, has this, they looked at in the hierarchy in the phase system, so they were recording an ML, and they were looking at pairs of phases, right? And what they observed is that the first part of the response in ML was like a feed-forward one, but then the second one seemed to actually have responses that would only come from the area above. True, they didn't, record in the area above, so they cannot tell you, but at least what that seemed to do is that it seems to change the coding properties of the neurons in an area that was not coding for that particular property. So, whether that is sufficient evidence, I'm not sure, but I think that there is more that says that these feedback properties can actually be there, right? And they can change the coding mechanism of a given area, right? That's one thing. The second is, does that then mean that, because you can also think of priors, as she was hinting to that, it doesn't necessarily have to come from an area above, right? It can just be lateral connections. That can also be, in that sense, I think that these are two orthogonal, like how those priors take effect. It could be because in the predictive coding, it comes from above, but also in the predictive coding, they also have a mechanism to do it just within an area, right? So it doesn't have to be.
Okay, we should move on. Thanks. The next speaker is Dominique Lamy from Tel Aviv University. And the title of the talk is, Have we been overestimating unconscious processing? Evidence from the liminal prime paradigm.
No, yours need to go. Okay. I'll show you. I think to send you that paper from Casper. Oh, sure, sorry.
Okay, thanks. Can you hear me? Yeah? Okay, so I want to thank Leon and the organizers for inviting me at this conference. So that's going to make two wonderful conferences in Israel about consciousness this year. And I hope that people who come from abroad will be encouraged to come back to Israel for the SSC. This talk is also going to be, like Liat's talk, a methodological talk. And I'm going to address the same kinds of questions, but I'm going to get to a slightly different conclusion. And I have bad news for Liat, because I think that ecological stimuli are passé My children spend like 75% of their time on a 2D screen. So we're going to stick to old stimuli. So before I start, I would like you to read this short paragraph, which is typical of most introductions on the study of unconscious processing. And basically, it states that the aim of comparing conscious and unconscious processing is to understand the functions of consciousness. But what is implied in this text is that in order to do that, it is only sufficient to demonstrate a significant effect of unconscious processing. So if we find, for instance, that I'm able to understand a word that I don't see consciously, then the conclusion is that I don't need conscious perception in order to read this word. And I think this is quite a jump for two reasons. The first reason is that, as Liad showed us, the effects of unconscious processing, and especially of high-level unconscious processing, are usually very small. Just to give a few examples, unconscious processing effects of less than 10 milliseconds are the rule. And nevertheless, the interpretation is very striking. Unconscious primes activate motor code through semantics. Mass primes can genuinely be semantically processed. A picture prime study, we see here a maximum of 8-9 milliseconds. Now, this problem is compounded by the fact that the standard paradigm that is typically used in order to demonstrate unconscious processing runs a high risk of underestimating conscious processing. I will first describe this paradigm, taking, for example, the seminal study by Stan Dehaan, and then explain why I think that it underestimates. Oh, sorry. I don't know what I did here. Just 1 second. I can take my glasses so I can see anything. Okay, thanks. Sorry. Okay. So most of you know this paradigm. It's you start with the main phase, which is the experimental phase, and in this phase, subjects see this typical sequence of events. You have a prime, and this prime is masked. It appears for a small amount of time, and the parameters are fixed such that people won't even be aware of its presence. And then you have a target, and in this particular case, the task of the subjects was to decide whether the target was smaller or larger than 5. And the prime could also be smaller or larger than 5, and the critical finding is whether responses to the target are going to be influenced by the prime. That is, if they're congruent, we're going to be faster than if they are incongruent. And the subjects are not even alerted to the fact that the prime is there at all, so they have absolutely no notion that it's there. And then to verify that, maybe I'm going to use this thing. Oop. No. Sorry. Yeah. Oh, it's only a pointer.
Yeah, it's only a pointer.
Oh, okay. Sorry. Okay. All right. No, it's okay. And then you have a second phase that comes at the end of the experiment, in which you want to verify that indeed the prime was not consciously perceived. And in this case, we have exactly the same sequence of events, but instead of asking something about the target, now the subject knows that there was a prime, and they're asked about the prime. And here there's a variety of different methods in order to verify the conscious perception of the prime. It's usually a discrimination task, and if you have, if your responses are at chance, then you decide that the prime was not consciously perceived in the main experiment. Okay, so there's a diversity of different types of discrimination tasks that are used. The most stringent one would be to ask about the very presence of the prime, but it is very rare to find such experiments, and possibly because of what Liad was talking about, if you reduce the visibility of the prime to the level where people cannot even say whether it's here or not, you're going to have very little to work with for your unconscious processes. So what has become more and more popular in the literature is what is called the direct-indirect match criterion, which means that if the property of the stimulus that's relevant for my unconscious processing is whether or not the prime is larger or smaller than 5, then this is the kind of discrimination for which the subject should be at chance in order for me to decide that he's not conscious of what's important for the task. And this is the task that is usually used. And as I will show, this task is problematic because look at what's going on. In this phase, I expect something that's not visible to affect my judgments on something that's visible. But then I ignore the fact that in this phase, I ignore the fact that something that's highly visible is going to affect my responses at something that's minimally visible. Okay? So what it means is that if I unknowingly respond to the target because it's more salient than the prime on a large proportion of trials, I'm going to be at chance on the prime discrimination because they're orthogonal one to the other, which means that I'm going to have spurious chance performance, and this is usually overlooked. There are other important criticisms about this paradigm. One is, of course, that in order to decide that I'm at chance, or my D prime is 0, what is called the null sensitivity problem, I need a lot of trials, which I usually don't have in these experiments. And, and most importantly, the two measures that are relevant for my conclusion, that is the measure of priming and the measure of consciousness, are obtained under different conditions at different moments. And this is the task comparability problem, which means that I might be in a totally different state during the awareness phase. And Rauder and Pratt have shown convincing evidence that when people are faced with this kind of task, in which basically most of the time they see something really faint, they lose motivation in performing the task, which means that they're going to have more or less random responses to the prime, which is not at all the case here because they have a very clear task to perform, and so their alertness is much higher. So the first problem we have is that the standard subliminal prime paradigm is likely to underestimate conscious perception, which means that the small effects we see might come from just a few trials in which the subject was aware, and we cannot draw very strong conclusions from this. The second problem is that, just to remind the text you read at the beginning, what we're really looking at is to what extent conscious and unconscious processing are different. And in order to do that, you need to compare conscious and unconscious processing. The problem is that with the standard paradigm, the prime is always subliminal, and therefore there's no conscious condition to which you can compare it. Now, of course, the implications of the comparison are really important. Suppose you find a 15 millisecond unconscious priming effect, which is on the high side of the distribution of effects in this field. The implications of this finding are going to be completely different if, when you compare it to a conscious condition, you get this result, which means that there is no effect of conscious perception, of conscious perception on the process you're investigating, versus this result, which would mean that conscious perception contributes very highly to this process. There have been a lot of research actually comparing subliminal and supraliminal priming. And here is an example of this. So in this research, what people are comparing, what the authors are comparing is a condition in which subjects are at chance at discriminating the critical stimulus, whereas they have a condition in which there is no mask, and so the stimulus is completely visible. And what you can see is that we have a very, very small effect here, and we have a huge effect when people are conscious of the stimulus, and yet the title of the paper is Prior Expectations Modulus Repetition Suppression Without Perceptual Awareness, and we get effects of repetition probability regardless of prime awareness. So there is a tradition of very strong conclusions based on very small effects, and when you compare conscious to unconscious perception, you see that the difference is huge. But of course, it doesn't seem to be surprising here because the stimuli are very different. So a more interesting case, which I will present here, is the case where instead of showing graded differences between conscious and unconscious processing, you actually show a dissociation between conscious and unconscious processing. And this is an old study, a very early study by Greenwald, who studied unconscious priming, compared it to conscious priming. So the unconscious stimuli were again masked, whereas the conscious stimuli were unmasked. And what they showed is that when you manipulate the time between the masked stimulus and the target, the unconscious effect disappears completely, whereas the conscious effect actually grows. Okay? So we have a dissociation here, but the problem is that we don't know where it comes from. What is important here? Consciousness per se. So consciousness with a conscious stimulus, my processing grows, and the effect on behavior is growing, whereas when I'm not conscious, the effect is going down. Or masking impairs the development of my processing of the stimulus, and this is why we get this dissociation. So without a comparison between conscious and unconscious processing with exactly the same stimuli, finding significant unconscious priming does not tell us much about the function of consciousness. So in recent years, a number of labs have been using a different paradigm, a modification of the standard paradigm, which we call the liminal prime paradigm, and which attempts to solve these problems. So in the liminal prime paradigm, we have a very similar sequence of events, except that on each trial, subjects first have to respond as fast as possible to the target, but then they have to rate the visibility of the prime on a scale from 0 to 4. Sorry, 0 to 3. This is a modification of the perceptual awareness scale by Overgaard, who uses a scale from 1 to 4, but our subjects found it more intuitive to rate absolute absence of visibility by 0 than by 1. And so 0 would mean I don't see anything. 1, I have a glimpse that something was happening on the screen, but I couldn't say anything about it. 2 is almost clear vision, and 3 is a clear vision of what the prime was. Now, what happens here is that we get 2 responses on each trial. Now, this paradigm has a number of advantages. The first advantage, of course, is that it allows comparing conscious and unconscious processing with exactly the same stimuli. And so if I look at 0, this would be my unconscious condition. And then if I look at ratings of 2 or 3, this would be my conscious condition. We usually drop the rating 1 because we have found it to be like the trash bag in which subjects use when they were inattentive or did not know what to do with the task in this particular trial. So we usually compare 0 to 2, 3 ratings. It compares conscious and unconscious processing in exactly the same trials and under the same attention condition, because basically both the prime and the target are going to be attended, and we have no task comparability problem. it also measures subjective experience at the lowest point, at 0. Now, you could speak about the criterion problem. Thank you. About the criterion problem, but several studies have shown that when you have several possible responses in order to express the fact that you're not sure what you saw, 0 visibility corresponds to chance performance on discrimination. So we're quite confident that 0 is the true 0. And in addition, it is not so much important in this kind of setting as it is in subliminal prime paradigm, because what we're interested in is the difference between conscious and unconscious. So basically, something that will show no difference will be independent of consciousness. And something that will show a huge difference will be dependent of consciousness, even if at 0, I do have a small effect. The other notable advantage is that it actually maximizes our chances to find effect, which is what was worrying Liad, because we don't need like savagely subliminal primes, because we do not need d prime equals to 0. So we can have like stronger stimuli, and these stimuli benefit from attention because people have to report on them. Okay? So we have ran in the past several studies in order to validate the paradigm. And this validation is just to show that it is sensitive enough to give the whole scale of different phenomena. So you could have instances of processing that do not depend on consciousness at all, and processes that are completely contingent on them. So here we have an example of attentional capture, which quite obviously does not depend on conscious perception. And another example of updating of an object information in working memory that seems to be completely contingent on contingent capture. On conscious perception. So the objective of the data I'm going to see here, to show you here, are the following. We tried to re-examine old questions about semantic priming. The first question that we are asking is, to what extent semantic priming actually depends on conscious perception? So as we saw before, there have been demonstrations of very small unconscious semantic priming effects. And the question is, how do we interpret these effects? Do we get something similar when people are conscious of the same stimulus, or do we get a big difference between the two? The second is, let's see whether we have unconscious semantic priming at all on 0 visibility trials when we avoid the caveats that are associated with the subliminal prime paradigm. The third question is, well, let's go back to the beautiful dissociation that Greenwald demonstrated with masked versus unmasked stimuli, and let's try to see whether we can actually find a dissociation between the time courses of conscious and unconscious perception. And the last question, which I think is interesting, is supposing that we do find a dissociation between the time course of unconscious and conscious semantic processing. Will that be true? Would we find such a dissociation for every other aspect of the stimulus, including low-level aspects? So this is what we tried to do in 4 experiments. So the basic pattern of the experiments with this one, we had numbers as primes and targets, which were masked. And we used the liminal prime paradigm. And we did this in 4 experiments. The task was always whether the target is smaller or larger than 5. And we had a target set that comprises of 4 numbers, 2, 4, 6, 8 in one group, and 1, 3, 7, 9 in the other group, counterbalanced. And so we had 2 types of prime sets. One prime set that overlaps with the target set, and one prime set that does not overlap with the target set. And I will explain later why this is important. So, supposing that your target is 4, you have 3 critical conditions. The first condition is when the prime and the target are identical. So the prime is 4 and the target is 4. The second kind is when you have compatible and incompatible digits that are in the target set. So in this example, that would be a prime of 2, which has been encountered as a target, would be compatible, whereas a prime 6 would be incompatible. And you have the same distinction here for novel primes, which were never encountered as targets. So this allows us to, I'm constantly tapping sorry. Sorry about that. So we can measure 3 kinds of priming. One is repetition priming, which means that we compare the case where the prime is identical and the case where it's different, but it is compatible. And it is part of the used prime set, which means that in this case, what we will obtain is a comparison between conscious and unconscious basic perceptual priming, which perceptual processing, which is not confounded not with conceptual processing or with response selection, because the same response is elicited by the 2 stimuli. The next priming we can find is response priming. So as I told you before, it is important to distinguish between used and novel primes, because when the subjects perform the task, with practice, they're going to form associations, direct associations between the perceptual representation of the prime and the response associated with it, because they learn it by associating the same representation of the target with the correct response. So at some stage, the conceptual analysis, or the semantic analysis, if you want, of the prime can be bypassed, and we have like stimulus response binding that are going to be automatically retrieved, and this will be reflected in compatibility effects with use primes that are different from the target. And then we have semantic priming, in which such associations are not going to help me perform the task. And if I genuinely process the target, the prime, unconsciously to the semantic level, I should get semantic priming. So we ran 4 experiments. We had novel, where are the escape here? Oh my gosh. Okay. We had novel and used for, I don't know where your escape, if you just show me where escape is, this is end show, that's the problem. You don't have an escape?
Yeah, there.
Oh, okay. I see. It runs from one to the other. I see. Okay. So we have 1 experiment for novel primes, and two experiments for novel primes, and 2 for use primes. And the difference between the 2 experiments in each category only had to do with very minor differences in the response. We asked. In one case, they reported their visibility reports vocally, and in the other condition, they used key presses, but this is not important. And there were 18 participants in each experiment. And what we did is what I showed you before. There are 2 things that are important here. One is that we forced the subjects to respond within a 600 millisecond window. And the reason we did that is because we found in previous research, together with other researchers, that after 600 milliseconds, the priming effect is completely disappearing. And most importantly, we manipulated the time between the prime and the target. So this is an example of an early study by Stan, in which indeed what you see is that if you look at the distribution of trials, after 600 milliseconds, the priming effect is completely gone. So in order to maximize our ability to find priming, we reduced the responses to 600 milliseconds. Okay, so these are the visibility ratings. What you can see here, this is 0, 1, 2, 3. What you can see is that both for novel and use primes, about 50% of the primes were completely invisible. And what is interesting here is that we found a significant effect of novelty. So it seems that novel primes emerge to consciousness with a higher probability than used primes, which is also an advantage of this paradigm in which you can compare the level to the probability of different classes of stimuli to emerge to consciousness. And this is the ratings for catch trials, and what you see is that in both sets of experiments, catch trials elicited a 0 or 1 or very low visibility responses for all subjects and in all experiments.
Can you remind me what a catch trial is?
Sorry, a catch trial is when there's no prime. Okay, so this is a very important condition because it allows us to evaluate the reliability of the subject's reports. So let's start with semantic priming. So here are the reaction times for the short SOA and the long SOA. And we have exactly the same stimuli in the conscious and unconscious conditions. So here we have only novel primes. And what we see here is that we entirely replicate Greenwald's dissociation in time of conscious and unconscious semantic priming. Okay, so with novel primes, we still have a difference between conscious and unconscious processing, semantic priming, which is not huge. I was very surprised to see this difference because basically it's like smaller by 30%. And then after 200 milliseconds, the effect is completely gone, and it is replicated with the accuracy data. Now we can look at the SR priming data, and to our surprise, they were extremely similar. So again, conscious priming tends to increase with time, and unconscious priming tends to decrease. So semantic priming depends on conscious perception, but it's not entirely contingent on conscious perception, and it has a dissociable time course. Now, I think the most interesting data come from the identity primes condition, in which what we can see here, on the errors there's nothing, but on reaction times, we get an effect that actually grows with time, and that is completely independent of consciousness. So with this paradigm, we could see cases in which the priming is entirely contingent on conscious perception, and this is late in time for semantic and SR priming. And we have a situation in which it's completely independent of conscious perception, which is the case for repetition priming. So to wrap it up, the summary of the findings here is that, well, semantic priming moderately depends on conscious perception. There is unconscious priming at zero visibility trials. They can be dissociated in times. And when one aspect of the stimulus becomes unable to affect my behavior, other aspects can actually have a growing impact, and that's what we saw about the identity primes, which reflect perceptual processing. Now, the conclusion is that at least for a simple manipulation of single digits, we're talking about semantic priming, but we have to remember what stimuli we're using here. So they are very simple stimuli. It seems that unconscious semantic processing was not overestimated. The present findings suggest a major dissociation of conscious and unconscious processes in time. And it shows that the liminal prime paradigm can be useful to uncover the functional differences between conscious and unconscious perception. Before I conclude, I would like to point out important limitations of this research. The first is that, again, we have used very, very basic stimuli for which we have what Kundo would call an action trigger. When I see the number 2, even if it's not in my target set, and I have been trained to respond to 3 as smaller than 5, then 2 might automatically get the same action trigger. And what we see here might be all of it stimulus response priming rather than truly semantic priming. And this is why we're running more experiments with different stimuli. Another important point here is that we have contrasted the identity priming and the semantic priming on the idea that identity priming reveals low-level processing and semantic priming reveals higher processing. But there's another difference, and the difference is that one is based on response selection. What we measure for semantic priming is the compatibility effect, whereas the other is not based on response selection, because in both cases we have an identical prime that is compatible or a different prime that is compatible. And this opens an interesting question of whether we are not mistaken in using response compatibility effects, because they might be the limiting factor and not actually the representations that can affect our behavior. So it would be interesting to find a different avenue for probing unconscious processing that does not rely on response compatibility effects, because it might be the case that very early on, the semantic representation, which is still well alive, does not affect my response selection anymore. And this is something that we're also trying to look at. The last limitation that I think is very important and might be an introduction to Leon's talk is that there is never a real liminal prime that has constant stimulation. It might have constant stimulation in the world, but not in my brain. Because if it did, then there's no reason why I could be conscious on some trials and unconscious on other trials. Which means that although we have tried to make the conscious and unconscious condition as close as possible, it's never perfect. And for proof, we're sometimes aware and sometimes unaware. But considering that there might not be any possibility to resolve this problem, I want to go back to Lucia's beautiful paper on the prerequisites and consequences of attention, of consciousness. Something will have to change in the prerequisites of consciousness for me to become conscious of the liminal price on some trials. But if we consider that there might not be anything in the middle, and our consciousness is simply the passage from prerequisites to consequences, then the liminal prime paradigm and the contrast that we try to establish between conscious and unconscious primes might be our best option. There is no such thing as a liminal prime that has absolutely constant external and internal representations to work with. I want to thank the funding agencies and mainly Mayan Avnon, who is here and who did most of the work.
Okay, we have time for questions.
Here's the microphone.
Thank you. That was beautiful, especially the condition about the identity and the idea that we might be misguided in looking into response contingencies. I wanted to raise three very small points about the liminal approach. So could it be that the results you're getting in the subliminal trials actually reflect some kind of effects that stem from the conscious exposure in other trials? Because we know, for example, in some of our experiments, subjects could perform a task on unconsciously perceived primes after they were exposed to them consciously, but if not, they wouldn't not. So in a sense, it might have been that there is no unconscious processing of these primes, but just because you learn to do it consciously, you are able to kind of take them to perform the task also unconsciously in the trials where you haven't seen.
Well, I think there are two different questions here. The first is whether our prior experience with a stimulus is going to influence not only our conscious perception but our unconscious perception, and that's definitely a possibility. Okay. The other question is whether what you're speaking about learning, but this is why we're separating use primes from novel primes. So if I have never been exposed to the prime as a target, so I have not learned to respond to it,
But
then
you were exposed to it as a prime.
right.
So-
So
so
Damien
you
in
can
2001 showed that exposure did not do the effect. Okay, so what they did is that they had a condition in which you were exposed to the stimulus but did not associate it with a response, and you got no priming at all.
So we have different findings that I'll be happy to share with
Okay,
you.
with-
And just two follow-up questions. One is, could it be that you still don't have the same task? So you don't solve the problem of task differences because the task that you perform on the target has a correct answer while the task you perform on the prime does not. So you might still want to devote more attention to the target as opposed to the prime when you are performing the task online, the two tasks. And subsequently for the prime task, how do we know that subjects can we validate their responses? So you have the catch trials, but they only protect us from underestimation in the sense that when I don't see anything, I don't say that I see something. But it doesn't protect us from overestimation. When I do see something, I still say that I haven't seen it due to some criterion issues. So
Okay, so that's why the important point in this paradigm is simply the slope of our findings. And this, resolve the problem is absolute invisibility, which I don't think is solvable. Okay, because I have a special interest in subjective consciousness. I don't think that chance discrimination or above chance discrimination tells us something about conscious perception. I'll just give an example. Suppose that you're looking at forced choice responses to the location of a stimulus. If I'm above chance, it might be because I saw something, or it might be because I'm aware of my eye movement, okay, to this stimulus. I might not have any experience at all, but some feedback from my physiological responses to the prime is going to inform me. So basically, objective performance can be informed by anything, not only my perception of the stimulus. And therefore, I don't think this is the paradigm of choice. Although, I mean, from my own reading of the literature, it covers about 70%, or 80% of the research done up to now. So what we're trying to push for is to change the paradigm to something that's closer to our conscious experience, and something that also asks the right question. The question is, what is the role, what is the function of conscious perception, not whether we can have a 8 millisecond effect for unconscious processing. No question? Yeah.
I was a bit surprised by the finding that for the novel primes, the visibility rated from 0 to 3 was actually higher than for the other ones, because for the other ones, for the non-novel primes, you expect some learning to occur, between stimulus and response. So that would automatically make them, well, at least in my mind, more salient. But the finding was the other way around. So how would you explain that?
One possibility is that something that's novel has special strength, which would be the nice and sexy possibility. The less sexy possibility would be that you are maybe more reluctant to say that you saw the prime because you have the target that competes with it. So sometimes when you think you saw the prime, you might say, well, maybe I didn't see it, and then it will go in the one category. I'm not sure I saw it because it might be the target or it might be the prime. So this is specific to this kind of design, and so I would not make too much of it. I still want to defend the liminal prime paradigm in asking this kind of questions, because, for instance, when you, for the research I showed on attentional capture, if you look at the chances for something that's relevant to your task, like suppose you're looking for something red and you have a red prime, red primes are going to be reported as visible much more than green primes that are irrelevant, which means that relevance increases the chances for conscious perception. So it might be a nice paradigm in order to differentiate better than BCFS, for instance, which is confounded with response factors. Here you don't have any response factors. All you have is the visibility ratings.
Thank you. It was a very beautiful layout of all the difficulties, and I completely agree with you that the new design is superior, and also that we care more about subjective perception, and this is what it is about. I still see a few problems. One is you still have the prime and the target. Could you get rid of the target, basically? Because otherwise, you just mentioned, for instance, maybe the repetition trials, perhaps you underestimate their visibility because the subjects cannot discriminate what comes from the prime, comes from the target. So in our work, we tended to get rid of the target whatsoever, ask a subjective question on every trial, like you do, but also have a forced choice task on the prime, the hidden object, and see how far you can go with processing in a direct task where you ask direct processing of the prime itself. What do you think of that?
So basically, what you hold to be your measure of unconscious processing would be forced choice performance.
How far can you go with forced choice, or how far can you go with activation also in the brain of a certain representation?
I think that forced choice is really an ambiguous measure. On the one hand, it is not perfect as a measure of conscious perception. On the other hand, it's not perfect as a measure of unconscious perception because I haven't seen real dissociations between subjective perception and forced choice performance, except for simple dissociations. So what I would need to see is a double dissociation between subjective perception and forced choice performance, which I'm not sure is around, because what we usually find is that they go hand in hand. So you might have above chance performance when you're at zero visibility, but this might simply mean that it's a more stringent measure for conscious processing or for other processes that are not conscious, but not necessarily for unconscious processing. I don't know if I'm making sense.
I'm not sure if I'm following completely, but for instance, with Couleur-Sergent, we had, I think, what is perhaps counts as a dissociation, preserved forced choice performance on the first order, but destroyed ability to detect your errors. For instance, error detection is completely gone when it's unconscious. So I don't know if that counts as
yeah,
the
but
sort of dissociation.
it's a dissociation that's a simple dissociation. You don't have like you don't have something that's going to grow on your objective measure and go down on subjective measure and the other way around. So what we have here, for instance, is between priming and conscious perception, we see that time affects them completely differently. What I would like to see is some factor that affects conscious perception measured by visibility and forced choice performance in different directions, because otherwise it always runs the risks to be somewhere along the line. I don't have the answer for that, right? But because I do think that in some cases it does reflect unconscious processing, but it's still a little bit unsure.
One last question.
It's more. It goes back to Victor's question. So you could probably actually make a plot or analyze how much the visibility changes as a function of exposure, right? And then have that as a control for the measure, right? So that's one methodological point. And the second one is in these two sets that you have, very nicely you have that the number 9 was never part of the task set because it was it was always novel. So you had the visible ones were, if I remember correctly, something like 2, 3,
You're right.
and 7, 8. But 9 is something that was never part of your task set. You never see it. So maybe that is your critical number because it goes away from the task.
But it was it was in different subjects. For instance, 1, 3, 5, and 7 were never seen by subject who had 2, 4. So it's not that it was in the same experiment and you had the two types of targets.
Oh, I see.
You have subjects who have only 4 numbers and other that have only 4 numbers. So there's the same status for the remaining five novel primes.
Yeah. But you could do so.
But it's
one of the digits never appears as a visible one.
oh, so it's always. But then I lose the liminal prime paradigm. The target is visible.
It never appears as a
As a
target.
target.
But this is exactly all the novel primes are in this category. Okay, so maybe something was not clear in my
exactly.
explanation. So
Yeah.
when I'm exposed to 4 targets, the remaining 5 numbers were never experienced as
Exactly.
so for both groups, 9 happens to be always novel, but it doesn't matter.
It matters in the sense that, you know, like, so if the ones that you have seen and you were part of your target are like, and this is a methodological point that Greenwell actually has made, like it becomes part of your task set. So you go from numbers between 8 and 2. And so you make your series, your
All right.
associations between those.
Okay, so
But
I
if
should
you
look
go
at, okay,
away
I see.
from those, then you don't have that. No, it's
I
not even part of
doubt
the
that
task.
you restrict it to 8 when you know your 10 numbers, honestly, but it would be
But they
interesting.
have actually looked at that, and it's
Yeah, but I think it was much narrower. So the difference is if I'm between small numbers versus far numbers, here it's only one above. I don't think they're going to be so sensitive to restrict their set to 8 numbers, but it might be the case. It's empirical, you're right.
Let's continue it during lunch. This is the end of this session. We